Welcome to the operations research course. So we'll continue with the transportation problem that we started for the past, the previous lectures. So in the previous lectures, we had discussed the transportation problem, how specific it is, but similar to a typical linear programming problem. And we have said that to solve the transportation problem using the transportation tableau, we need to ensure that the problem is balanced. And when it's balanced, then we can then solve the problem using the transportation tableau. So we have gone through how to determine the initial solution using the northwest corner method and also the Vogel's approximation method. Then after obtaining the initial solution, if we want to solve the problem or we want to find the optimal solution, we introduce the stepping stone method. And in this lecture, we shall be looking at the second method called the modified distribution method, simply called MODI. So stay with me as we walk through this lecture. So the modified distribution method in finding the optimal solution of a transportation problem, it actually differs from what we did in our previous lecture, that is the stepping stone method, in the sense that, in the stepping stone method, we have to evaluate all the non-basic variables or all the empty cells in the tableau, right? However, in the modified distribution, instead of evaluating all of them, right, we actually determine the closed path, by defining values associated with each cell in the row and also each cell in a column. So we use the value UI to define cells in the row. So we say row 1, row 2, row 3, that is U1, U2, U3, U4 in that order, right? Then we also define the VJs representing cell values for each column. So we have V1, we have V2, we have V3, we have V4, and so on. So we do that evaluation for each basic variable, right? We use that evaluation. So we say that for each the basic variable, the decision to allocate depends on the associated unit costs, for each cell, right? So the CIJ is actually the associated unit cost, right? So that is done. And then we later find out the one with a penalty cost, or the unit cost that has the most negative value. That means that it will contribute in minimizing the transportation cost. When we identify that, then we initiate the stepping stone for that non-basic variable or that empty variable. So in summary, what the MODI method does, or the modified distribution method does, is that one, we determine the various values associated to the rows, that is the UI's values for each row and the VJ values for each column, right? For all basic variables using the relationship UI plus VJ is equal to CJ. So this is the relationship that we use, right? So usually when we do this, then we assign 0 to any of the values, but usually the UI is assigned before everything is done solved. Then what we do is that we compute the next cost change. So the net cost change is computed for each non-basic variable using this expression, right? The existing unit costs minus the UI minus the VI, right? So if a negative unit cost change is found, right, or exists, then the solution is surely not optimal. right? So we select that Xij or that non-basic variable that needs to be allocated, right? That has the highest negative value, right, as an entering non-basic variable. And then we allocate as much as we can in the non-basic um, variable cell, right, according to the stepping stone process, which we've done already, right? So we repeat X1, that is, we iterate, we continue the iteration until there is no negative net cost change, right? So if there is no negative net cost change, then we see that the solution is optimal. So again, we'll go to our whiteboard and we would use the initial solution to the northwest corner method that we had for this particular problem that we are using, and we'll demonstrate the muddy method. So stay with me as we move on to our whiteboard. So that's it for the northwest corner method. So there's an initial solution, right, from the transportation problem. So what we do here is now to determine the UI. So we want to determine U1. We want to determine the value for U2. We want to determine the value for U3, right? The same thing is done for V1, for V2, and for V3, right? But we evaluate the basic variables, right? We evaluate the basic variable, that is the occupied cells. So for the basic variable X11, right? Remember Xij, right? Let's put in the Xij, doubles of Peter problem. So for X11, right? That means that it's made up of what we call U1 plus V1, right? Will be equal to the C11, that's the cost of transporting from one source to destination one. All right, C11 is actually 8. All right, good. So we actually don't know the value at this stage, right? So we also create the next one. The next occupied cell is X21. So X21 will be U2 plus V1, right? And it's equal to C21. And C21 is actually 15. Then the next occupied cell is X22, and it's given by U2 plus V2 is equal to C22, and that is 10. Then we have X32. X32 is U3 plus V2, and it's equal to C32, right? Which is equal to value there, 9. Then the final one, occupied cell, is X33, which is U3 plus V3 is equal to C33, and C33 is 10. All right, so we can now evaluate this, okay? We can evaluate this and see that so we say that if U1 is equal to 0, right? So we take one of the values or one of the unknown values, the Uij's, to be equal to 0. And usually the first one is made 0, right? Good. So remember that before you do this, you have to check your n plus n minus 1 condition, right? So this is 5. So we have 1, 2, 3, 4, 5, right? Good. So 5 unknowns, right? Or 5, yeah, we need 5 unknowns. So no, 5 known, right? 5 occupied cells to make sure that it is balanced. If not, we have to treat it and we'll look at what to do if it's not up to that value. All right, so if U1 is equal to 1 from the first equation, then it means that V is equal to 8, right? If b is equal to 8, then it means that for this second equation, right, u2 is equal to 15 minus 8, and that is 7, right? The same thing, now we know u2 here, we don't know v2, so v2 will be equal to c2, which is 10, minus the 7 is equal to 3, right? And this equation, we don't know u3, so u3 is actually equal to 9 minus the v2, which was 3, 6. Then for the last one, we don't know we know u3, so we don't know v3. So v3 is equal to 10 minus the 6, and that is 4. And that is 4. So what we do here is that then we put these answers around our tableau. So u1 is equal to 0, u2 is equal to 7, right? u3 is equal to 6. v1 is equal to 8. v2 is equal to 3, and v3 is equal to 4. All right, so from here, right, we have computed our UIs and the VGs, right? We have computed our UIs and the VGs for the basic variable. So what we have to do is that we have to now find the net cost change, right? The net cost change, which is the CIJ asterisk or prime, right? Yeah, we have to now determine for each non-basic variable, that is each empty cell, right? For each empty cell. So what we'll do is that I will erase this equation, right? So that I can use this part of the board to determine that. So we are now determining the net costs change, which is CIJ asterisk, right? So we are determined for each non-basic variable, right? Non-basic variable or empty cell. All right. So what we'll do is that, what are the empty cells here? The first one is C1, 2, right? So just to remind us, so we are dealing with Cij prime, right? Is equal to the Cij minus Ui minus Vj, right? So what we'll do is that we will find the first empty cell, which is 1, 2, and we evaluate it. So 1, 2 is made up of 5, it's already there, minus the U1, Ui. So U1 is 0, you know. Okay, let me write the expression here so we will understand where we are getting all these values from. U1, V2, right? So this will be 5 minus 0 minus 8. V2 is 3. V2 is 3. Yep. And that will be 2. Now C1, 3, right? Prime or asterisk is C1, 3 minus U1 minus V3, right? And this is the here is C13 is 6 minus U1. So let me get rid of this. So 6 minus U1 is 0, minus V3 is 4, and that gives us positive 2. Now C23 prime, right, is C23 minus U3 minus V, U2 minus V3, right, and that will be 12, 23 is 12, minus U2 is 7, and V3 is 4, and that gives us positive 1. Then we have C, the last one, C31, right? The next change, the next change is C31, that's the cost, minus U3 minus V1, and that will be 3 minus U3 is 6, V1 is 8, and this will give us negative 11. So you can see that the net change C31, right, asterisk, is less than 0, and it implies that the present solution is not optimal, and therefore we could allocate X31, right, and treat it as entering non-basic variable, allocate as match there, and get the new transportation arrangement. So what do we do now? Now we employ the stepping stone and say that let's go to X13. So this X13. So the X13 will allocate this region positively, right? So using the stepping stone, we allocate this positively, right? And that means we have disbalanced the system, so we have to allocate a negative value here. We balance, to balance the system, we have to allocate a positive value here. Then we come down, a negative value here, and we are back with a closed loop, right? With a closed loop. So how do we then make these arrangements? So it means that the 20 moves to the 20 here, then goes to X21 to reduce the 30, and it goes to add to the X22, then it also subtracts to the F22. So our next tableau, will be, so the iteration is done that the 20 comes here, it goes up here to become negative and therefore reduces the 30 to 10. It comes here to increase the 50 by 20, and it goes to 70. Then it moves here and makes it 0. All right, so to clean up this, so that's the final, so the iteration, right? All right, so this is the second tableau, right, from the initial solution. All right, so now we have to again check for optimality by checking the various occupied cells, right? So we check the various occupied cells as we did before by evaluating all the basic variables again, or the occupied cells. So we evaluate the cost, and we say that what is the cost for C11, right? The cost for C11 in terms of U1 plus V1, right? So we do this so that we can determine our various UIs and the VIs, right? So we are determining all these costs, but we know that this is equal to 8, right? So it's 8 is equal to U1, and we can say that if U1 is equal to 0, right? So it's equal to U1 plus V1, and that means that V1 is equal to 8, right? Then we look at C21. So T21 is U2 plus V1. And what is CU2? That is 15. So 15 is equal to U2 plus V1. Now we know V1 to be equal to 8, so 8, right? And that means that U2 will be equal to 7. All right, let's evaluate C22. So T22 is made up of U2 plus V2, right? And what is C22? That is 10. So 10 is equal to U2 has already been evaluated as 7 plus V2. And therefore V2 is 10 minus 7, and that is positive 3. Now we look at C31. So C31 is U3 plus V1, right? And when you evaluate that C31 is 3, it's equal to U3 and we evaluated as on, so we don't know that, right? Plus V1. So we already know V1 to be 8. V1 is 8. So when we do this, then U3 will be equal to 3 minus 8, and that is minus 5. All right. Then three, 3, right? Now we are evaluating the occupied cells. C33 is U3 plus V3, right? And C33 is 10, so 10. U3 has already been evaluated as negative 5 plus V3, and therefore V3 is 10 plus 5, and that is 15. All right, so we can now come back here and put our values here. So U1 is equal to 0, U2 is 7, U3 we found negative 5, V1 is 8, V2 is 3, then V3 is 15. All right, so now when we have this, then we have to now evaluate the non-basic variables, right? We evaluate the non-basic variables. So let's do this evaluation here. So the non-basic variables, or what we say the empty cells, right? So in evaluating the empty cells, all we are doing is that we are finding the next change, right? The next change, ij, right? So let's put it here. ij is equal to what was the equation? Is u c the existing ij minus ui minus vj. All right. So if I take the first empty cell C12, right? So if we are evaluating C12, then we can say that the C12 is made up of A12, the next cost change, right, is made up of C12 minus U1 minus V2, right? So what is C12? The value is 5, so 5 minus 0 minus V2, which is 3, and we have 2. C asterisk 13 is C13 minus U1 minus V3 And that will be what is C13. The value is 6. So 6 minus 0 minus V3 is 15. And the value is negative 9. Okay, so we have 2 more to go. All right. So C23, the net cost change is C23 minus C2 minus V3. And C23 is 12 minus 0 minus 15. C23 is 12. Oh, U2 is not 0. U2 is not 0. It's not 0. What is U2? U2 is 7. Yep, it's 7. So this will give you negative 10. Then the last one, C32. Yep, C32 is C32 minus U3 minus V3. And if you should substitute U3 is 9. So 9 minus negative 5, that is U3 is negative 5, minus B3 is 15. So 9 minus negative 5 is 9 plus 5, and that is 14 minus 15. Sorry, so it's V2. Now this is why I like operation research. It would humble you. It would humble you and let you be careful. So B2 is, what value do you have here? It's 3. Yep. It's 3. So 9 minus negative 5 is 14 minus 3, and that is 11. All right. So we can see that the empty cell C23 needs to be allocated. So needs to be allocated, right? So we'll go back to our tableau and find C23, and that is C23. So C23 is here. C23 is here. All right, so how do we allocate here? Stepping stone, right? So we use the stepping stone here, and we find the loop that do this allocation using the stepping stone. So we have plus here. I move here to negative. I move to the left to the plus. I move to this cell to the minus. I come back here and it's negative. All right. So it means that I must allocate in X23, right? So how much can I allocate there to balance? So I can only allocate. So let's do the allocation. You can allocate 10 because there's already 70 in X2, right? So we can only allocate 70 here. Then the 70 will then change because it's positive, it moves down to be negative. So it changed the 60 to 50, right? Then it goes to the left because it's 50, it must balance, so it adds plus 30. Then it goes here to take this out, right? So if I should clean the tableau, I'm going to have this table. All right, so this is that tableau. All right, so I think this one is clear. So what we have to do again is to evaluate the basic variables to see if there is no, if all the net cost changes, are positive, and therefore there's no need to have any empty cell being reallocated, right? So we will look for our new UIs and VJs, right? And use that to compute our new net cost change, right? Then we can see whether we are getting a negative value or all of them are positive value. And therefore, this becomes our optimal solution. So let's do that. We compute our new V1, new V2, new V3, new U1, new U2, new 3. Okay, from the basic variable. So what we do is that we say C11 is equal to U1 plus V1, right? So it states it's equal to 0. So assuming if U1 is equal to 0, so it's equal to 0 plus V1, and therefore V1 is equal to 8. All right. C22 is equal to U2 plus V2, and we have 22 is 10, so 10 is equal to U2 plus V2. So assume we can calculate this. So let's see the next one, C23, right? So C23 is giving us U2 plus V3, right? C23 is 12, and U2 plus V2, so we don't know, so we'll come back to this. So C1, 3, no, 3, 1. Sorry, so C3, 1 is equal to U3 plus V1, plus C3, 1 is 3, is equal to U3 plus V1, we know it to be 8. So it implies that U3 is equal to 3 minus 8, and that is negative 5. All right, so that is negative 5. Okay, then we have C3, 3, which is U3 plus V3, right? And C3, 3 is 10, is equal to U3 is negative 5 plus V3, and therefore V3 is 10 plus 5, and that is 15. All right, so we can go back and find our U2. So U2 plus, we know V3 to be 15, and therefore U2 is 12 minus 15, and that is negative 3. Then now we know U2, so we know U2 to be negative 3 plus V2, which implies that V2 is 10 plus 3, and that is 30. All right, so we must fill this table. So U1 is initial 0, U2 we found negative 3, U3 we found negative 5, V1 is 8, V2 is 13, and V3 is 15. All right, so now after obtaining this, then we have to evaluate our non-basic variables. All right, so let me clean this so that we can do the evaluation here. Non-basic variables, which are the empty cells, right? Good. So for us to evaluate the non-basic variables, right, to check for optimality, we look for The first one is the net change here, which is C12, and C12 is C12. Remember, there is the formula Ij asterisk is equal to Cij minus Ui minus Vj, right? So C12 prime or asterisk is minus U1 minus V2, and that will be 5 minus U1 is 0, V2 is 13, and 3 minus 13 is -3. So you see negative, it means that there is one more iteration, or there is a next iteration to do. All right. So the next one is C13, and that is C13 minus U1 minus V3, right? And C13 is it's not the asterisk, the C13. So C13 is 6 minus 0 minus 15, and that is -9. Okay, -9. So we'll do for the rest, and we'll have this. Therefore, which one is the most negative? That is this, which is the C13. So X13 needs to be reallocated, right? Needs to be allocated as much as we can, so that we can see whether we are getting closer to that. So what that means is that we have to allocate X13, that is this section, right? So we then go back to our stepping stone, and we say that this will be plus, right? And it moves here to become negative, moves here, moves here to become positive, right? Moves up to become negative. Then we come back, so then we close the loop. All right, so let's do the allocation. So it means that we're going to have, we need to take some value here and add some value here. So what we'll do is that this section becomes 50 because it comes here to take this out, right? Which is completely 0. It comes here and it adds to this, so that we'll have our 80 here, and come here and it subtracts from that, and we have 70 here. Okay, so to clean the table, we shall have this. So that's our new tableau, right? So that's our new tableau and our new iterations. Okay, so what then do we do? We have to then go back and check all the occupied cells and find out which one, calculate the new UIs and the new VIs. Use that to check the optimality of the tableau by evaluating each empty cell. Then we can see if we don't have any negative value, then we'll say that the solution is optimal. If we do, then we'll continue our iteration. So let's go back and let's recalculate the UIs again. So we are going to check the basic variables, which are the occupied cells, right? We are going to check the occupied cells. So let's do this. Yeah, check the occupied cells by determining Xij is equal to Ui plus Vj, right? Then we can determine the various new UIs and the new VJs. Okay, so we can call in all this. Evaluate the basic cells. So the first one is C11. It's equal to U1 plus V1. Right. So again, if U1 is equal to 0, right? So this implies that 8 is equal to 0 plus V1, and therefore V1 is equal to 8. All right, so let's see C13. So C13 is U1 plus V3, and C13 is 6. U1 is 0 plus V3, and therefore V3 is 6. C22. So C22 is U2 plus V2, and that is 10. U2 is unknown, V2 is also unknown, so we'll come back to this. So C23 is U2 plus V3, and that is 12, is equal to U2 is unknown, but V3 is known as 6. So that means that U2 is 12 minus 6, and that is 6. So here we have 10. Then we know U2 to be 6, plus V2 is unknown. So V2 is equal to 10 minus 6, and that is 4. Then we come to the last one, C31, which is U3 plus V1, right? And C31 is 3. U3 is it known? No, it's unknown. Plus V1 is 8. So we can have U3 is equal to 3 minus 5, and that is negative 5. So negative 5, so we have negative 5 here. U3, U1 is 0, U2 is 6, V1 is 8, V2 4, and V3 6. All right, so now we have determined our the UIs and the VJs, right? So now let's evaluate the non-basic variable, that's the empty cells. That will then help us to check for optimality, whether there is a net cost change, which is negative. If it's negative, then it's going to affect the objective function. If all of them are positive, then it means that any reintroduction will rather increase the cost of transportation, and therefore it's not optimal. So there's no need to do that. So let's do that, and let's check for our non-basic variables or the empty cells. So non-basic variables, which are the empty cells. So we are going to check for optimality, right? And there is the formula that we use. Xij asterisk is always equal to Xij minus Ui minus J. So let's check the first one. So the first one is C 1, 2, right? So C12 is C12 minus U1 minus V2, right? So what is C12? C12 is 5 minus 0 minus 4, and that is 1. Okay, now C21. So C21 is U2 minus V1. And what is U2? U2 is, so C21 is 5. No, C21 is 15, yeah. Minus U2 is 6. V1 is 8. And what do we have here? 1. Yeah, then we have C3, 2. The net cost change. And that will be C32 minus C3 minus V2. C32 is 9 minus -5, and minus V2 is 4. So this is actually going to give us 9, 14 minus 4, and now will be 10. Then the last one, so at this point, we should be celebrating because we are not seeing any negative value there for our net cost change, and therefore we are getting closer to not doing the next iteration, which is good for us. So C33 is 10 minus U3 is -5. Oh, good for us. And V3 is 6. So that is 15 minus 6, and this is 9. All right, good. So here we'll see that the net change, right? All of them are greater or equal to 0. This implies that there is no possibility of reducing the cost further, right? So we'll say that the solution here is optimal. And if it's optimal, then simply all that we are saying is that X11 is 70, that is 70 should be transported from the source 1 to destination 1, right? X13 is 50. 50 should be transported from source 1 to cement from source 1 to destination 3. X22 is 70, meaning that 70 should be transported from source 2 to destination 2. 3 is 10, and then 1 is 80. So this is the modified distribution, right? So what all this means is that for the modified distribution, find the UIs and the VIs for each tableau. Use that, find it from a basic variable, right? From the known solution, or from the known value, or from the occupied cell, right? Use that to check the optimality by evaluating each net cost change of the non-basic variable, right? And then we can, if there is a negative net cost change, it means that the solution can be improved, and therefore we use the stepping stone to do the reallocation. All right, so on this note, I want to thank you for joining me, and we'll meet in our next lecture, which will look at when we have an unbalanced transportation problem and other complications in the transportation problem. All right, so until then, thank you very much for being with me, and have a good day. Cheers.